what we are supposed to do and what we are not supposed to do in the RF side. In order to apply the electrical signal to the devices we have in the lab, we must be sure that the connectors, the cables, all of them are matched with each other because they support different baud rates. When they support different baud rates, the physical structure of these connectors, cables are different than each other, so we cannot directly connect everything to each other. So I show you the typical connectors, cables we have in the lab. We have you guys generally is supposed to work with 3 types of connectors, cables. By 3 types, I mean we have a document in the lab. This document you can get it from Natalie. You know Natalie. She can send you the PDF file of this one. So we have 3 categories, more than 3 categories, but in the lab usually we work with 3 categories. We call it V, K, and SMA. These 3 are the main components that we are using. We have more than this one, but generally we work with these 3 types. So K, V, and SMA. We, in order to recognize them, we color them. So V always is red. V always is red. This one is red. Blue is K. Blue is K. And SMA is black. What's the difference between these types? Their bandwidths are different than each other. You can see it in this table. SMA usually supports up to 18 gigahertz. Blue K supports up to 40. And red supports up to 67 gigahertz. And now we check them. For example, if I want to connect this cable to a device, electrical device, and after that to another device, sometimes they do not match with each other. There are 2 types of connectors, female and male. Female, let me see if we have a female here. Female, always there is a hole. You can pass it on to see that. In the male types, always there is a pin. Okay? So, some devices have only male output. In order to connect the cable to that, you need a female connector. Yes. For example, if I want to connect, this is a male cable as a pin. You can see it? If a device output is male, I cannot connect it. I have to use a converter to convert the male to the female. This, so far we have, I said that we have 3 types of the devices here, support different bandwidths, K, V, and SMA. We color them. K is blue, V is red, SMA is black. Also, each type has male and female. Now, assume that this cable, tell me the type. No, tell me, don't watch it. Tell me, what's the type? And do not bend this.
Male.
Male and type? Blue. K, yes. So it supports K up to 40 gigahertz. You want?
Mm-hmm.
You tell me, what's the type of this cable?
It's male.
Male and type? You can check it here.
K.
No, it's not K.
Blue.
Check the color.
And this color.
SMA. Yeah, exactly. And you? This one?
Yeah.
So it's a male connector. It's a male connector, and it's gray, so it's...
this color is red.
Oh,
so
okay, it's
check-
for the end, right.
Yeah.
So the red is the V type
Yes,
towards a K type.
exactly. That's right. Sometimes in the cables you see no color, or after because of aging the color goes away. So you need to recognize it by just watching the pin or the hole. SMA is so easy to find. SMA always there's a white material inside that one. All the connectors, cables has a white material. Check these ones. There is a white ceramic material inside that, so SMA can easily be found in the lab. No problem with that. If there isn't any black color on top of that, you can just check it by this white material inside that. But the problem is with the V and K. It has a V. Okay. Red and blue, exactly. Red has a very thin pin inside that, but the pin inside blue is thicker. So there's another way to recognize it.
So, SMA is white?
Always white.
All white are SMA?
Yes. Material inside it is white. So you see that its size is different. Are you okay?
Yes.
You see that. So just see them. The red and blue, the difference, the pin inside that is different. One of them is thicker, one of them is thinner, and also the outer circle is the size is different.
So we cannot put
Like them together?
like another
No,
kind.
no, because the size of the pin is different.
We cannot match.
Yeah, when you want to put it inside the other one, female one, since one of them is wider or thinner, either it breaks the device or there isn't any good connection between them. So far we are good?
Yep.
Okay. Sometimes the output of the devices, I have a device here, I can show it. Filming is not important. Come here. This is our real-time sampling oscilloscope. We capture RF signal with this one. It digitalizes the signal, converts the analog signal to the digital. Here you see that it's blue and it's female because there is a hole inside it. You cannot see it from there, but I tell you it's a female. And this one is red and it's male. Usually the things that has a knot around it, it's a male. These ones are female without a knot. So if I want to connect a cable to this device, if my cable is blue, I cannot connect blue, which is K, to the red one, V, because the size of the pin and hole does not match each other. So I need a converter to convert the K type to the V type. The converters are here. We call it adapter in the lab, and we always store it here. So whenever you need something, connector, come here, take it from here, from these boxes, and put the box inside this one, because they are very small, tiny pieces and they can easily get lost and they are expensive. For example, this one is, I can measure. Check this one. It converts the male to the female. And this one for the just pass it.
Female to female?
Yeah, female to female. Sometimes we need it. Female to female, male to male. So the types we have, male to male, female to female.
Male to female, yes?
This one is female, female, both sides.
No, convert.
No,
Male.
they didn't
Yeah,
convert
just the bridge.
So,
type.
yeah, exactly. So,
It's a
for
union.
example, we can use
To make
two,
it longer.
Male on both sides.
Ah,
If, for example, sometimes the length of the cable is short, you want to extend the length of the cable. So we have all types of that, female to female, male to male, male to female. This is just in one color. We also have in converting to different colors. This one is converting the V to the SMA, red to the black. Black has always white material inside that one, so you can easily find it. Just pass it. This one converts, you tell me. No. No, just check it here.
Blue is K to V
Wait,
and matte to matte.
that's right. Sorry, will you tell me?
Yeah. The V to K
Mm-hmm.
And male to female.
That's right. You tell me, Daniel.
Yes. So that's a male to male,
I thought.
male to male,
Mhm.
V to K, V to K.
Okay, that's right. And to answer your question, how we categorize them, we just put a label here,
Yeah.
black, we wrote it SMA.
Yeah.
This one converts the red to red, two dot reds, adapter, like that. Red to blue, adapter.
Yeah.
And this one is another type of the connectors, they call it, let me see, they call it BNC, yes.
Yeah.
And the baud rate is 4. Usually it's larger, but again it's white. You can see here.
This
Yeah.
is usually
Standard BNC cable.
Yeah. For example, when I use my experiment usually is high baud rate, so I usually do not use SMA or BNC connectors, adapters. But sometimes I need it. When I need it, let me show you in the setup. When I need it. Here,
your setup?
Hmm?
It's your setup.
yeah, it's my setup. This is a power supply and we have an earth. You want to make, connect the earth of some of the devices, make it common. So we use it here. So always use it for very that's a very small frequency signal. For example, if the frequency is less than 4 gigahertz. Less than 4 gigahertz, so I can use this as a DC source. So I use it for just connecting the earth of the ground of some of the components to the power supply. And after that, I make all the grounds connected to each other, so I can extend the distance. And now about how we can connect the components together. For example, this one is blue and it's male, and I want to connect it to the, for example, female red. So I need to, this side must be female red. Female red is like this, female red. But this side is male, both sides is male, so I have to convert male to female, and also this, they do not match with each other because this is blue, this is red. So I have to convert it. How I can convert it? I can convert it. Yeah. Sometimes there isn't any color, as I told you. Can you tell me what's the type of this one? When you cannot find it easily, you can compare it with the colored ones. So I give you two different things. You can compare the size.
It's not SMA.
Because when
It's not SMA, there's no white
Exactly.
first. And I think it's hard to
Size
say.
of,
I think it's a V. Yeah, so it's the red type. I think so.
That's right.
Yeah,
It's big.
slight difference, right?
You tell me, what's the type of this female
V
connectors?
is really small.
Yeah, it's very tiny.
no.
red is a small,
Yeah.
so I think it's related to the
Yeah, it has to do, right? Smaller the
smaller, smallest, smaller, small.
yeah. That's it.
The one without the color.
There are two things. One of them is hole and the size of the hole and diameter of the hole and pin, and also the outer circle inside that. For example, you can see it here. There is a circle inside it. I do not use that circle
Okay.
on the pin, but also there is a, you can recognize this where the K is thinner circle, thinner
Oh.
ring. This one, V has a thicker
Okay.
ring.
Okay.
Okay, did you decide what's the type?
Oh.
Yeah. It's blue. But they put it in the red one. They made a mistake.
Always condition.
You'll always be careful. So, This one is blue. And you said that this one is red. You
Yep.
verify that. You check it. This side does not have a color, but it's red. Because if you compare it with the blue size, one of them is smaller. The smaller is big. So, I want to connect the cable to the connector. How I do that one? We have two devices here. One of the torque, one of them is, I don't know what they call it, something like an adapter to hold the nuts around the connectors. What I do is firstly put the matching size towards each other, make it closer, and put it inside each other, male inside the female. After that, you start rotating the nut around the male one. Always rotate the nut. Do not rotate this one. Do not do this one. Always rotate the nut. Fix this one with your hand. Rotate it until a point that you cannot do it with the pressure of your hand. But you have to make it tighter. All these connectors has an edge around that. Let me show you. See, it's not just a circle. There is an edge, right? Do something easier. See, it's not a full circle. There's a edge around that, right? Okay. So I use that edge. I use this device to fix that edge. Definitely one of these ones match with this adapter. I can put it inside that edge. See, when I put it inside that edge, it will not rotate, it will be fixed. So I can hold this one. After that, you use this torque to rotate it. Always hold the rope from the top because it's designed for these connectors, KV and SMA. When you rotate it, after a point you hear a click. Yeah, it means that the pressure isn't enough. Because the pressure is fixed for these types of the connectors. It returns. Yeah, you can see that the pressure is returned. So it's a fix, you don't need to know the number, but I just know that it's designed for fixing this connector. If you put more pressure, you can damage the connectors or the cables. So I fix this one. Then I can turn it back to the, for example, I can change it the other side. This one was blue male, I can turn it to the female red. So I just need to put it inside this one. We put the female inside male. We turn the nut. After that, we use this device. It's from SHF. Find the right size. Then fix it until you hear the click. So I want you to connect a couple of devices to each other. Okay. One of you connect, the other one opens it. We start with Daniel. For opening, again the same. First we fix it with that card. Then we again open the opposite side with the torque. Use the main one, the nut around that one.
There we go.
Mm-hmm.
And I use this. Okay. It's probably not the best way to hold it, right?
Yeah, sometimes it's
There we
challenging
go.
to find the right angle.
And then
Yeah, that's always just use the top of the
tip.
torque.
Okay.
Yeah, because from here the pressure will be different.
Oh, right. Okay, makes sense.
Yeah.
So, should I?
You can pass it to him.
Yeah.
You can open it. Just remove it. Okay. Not with hand. I give you
It's
this
been torqued.
text.
Yeah.
You want to open this nut, so you have to fix this side.
What's the procedure for sneezing in Syria?
Try not to, because it will affect your results. See that table? Even that table is so sensitive to the vibration. If I touch the table, it can affect my performance.
So, outside of the
Hmm?
you should sneeze or
No worries about it. You can insist, but not on the open components. Take it out. No, you start. It will open. Yes, sir.
Yeah.
Okay. Yeah, it is. You're working with Sufi or
Wait.
Wait? Okay. You're very no Sufi? I thought you were very. And here, down here. Right, doubles. Never do it with pressure. If you see that this stuff does not rotate well or does not go well inside the other adapter, do not put pressure. Either one of them is broken or it's not on the same line
It's
direction.
aligned.
Yeah. As the bandwidth goes upper, it gets more expensive and we have less of them.
Before using any of these, we should ask someone to give those to us or
No.
on ourselves.
Yeah, you can come here and take it. Just do not take it from the table. Yeah, that's it. And after you finish your experiment, you always have to return back all the components to its place. We have a problem in the lab when we want to start experiments. We have to go room by room to find the equipments because,
After using them,
for example, I want to start an experiment here, but I cannot find the equipment because people who already use it didn't bring it back. So I have to search room by room to find the equipment. And these components easily go underneath of these devices, and you cannot find it.
it's not easy to find.
See where are you going? Go. Okay, perfect. Good. So, this was about the connectors. The cables are almost the same. We have KV, SMA. We usually keep the cables here, but not always because people take it. So this is the cables that we, here we keep the cable K and V. You will see different types of the cables. Some of them are very thin, some of them are very thick. For example, if you check that, it's SMA, but if you check it with this one, both of them are blue. They are supposed to K. But we check the bandwidth, their bandwidth is not the same. This one has lower bandwidth than this thicker one. This thicker one has higher bandwidth. I think the bandwidth of this one is around 30. Once we check this one, although it's blue, it's supposed to support up to 40, but the 3 dB bandwidth is around 18 gigahertz. And some of them are metal. See that the shield is metal, but I think the bandwidth is very good, but the problem is that after a couple of times that we use it, it gets broken from here, and we cannot use it anymore. When you want to use the cables, be sure that do not bend it too much, because first of all, there's a limit in bending of the cables. Secondly, the number of the times that we can bend the cables again is limited. I don't know the value, but one of the technicians in the past told us we are allowed to bend it limited times. We try to avoid it. Let me show you something on the setup here. Sibo and someone is supposed to work in this setup. This is our DAC, this is our SF modulator. See, I use the cables to feed this is our SHF modulator. So I want to feed the modulator with electrical signal. The electrical signal generated by the DAC. So I use the cables. Sometimes it's impossible not to bend the cable, but just be sure that, for example, I cannot bring the DAC so close to the SHF, because in that case, it will be bended. Also, see, we didn't connect the cables directly to the device. We use these adapters in the middle. Do you know why we use adapters in the middle? I didn't directly connect the cables to this one.
Nothing moves or pulls on the circuit, right?
And finally,
So that it's grounded.
for protection.
Okay.
Because if this cable damaged, you have to probably return back the DAC to the manufacturer to change it or repair it. But if the connector or the cable damaged, you are fine. So we put adapters on many components in the lab. In the DAC, in this modulator C, we put the connectors. Although we couldn't connect it directly, but we put a connector. And we said that we will never remove these connectors.
So the connectors are fixed.
We fix it. I mean, it's not fixed, but we just close it and ask people not to open it. Always connect the cables to those connectors. And another important thing is, when you want to touch the devices, electrical components, always use ESC protection. The bracelet like this one, it connects you to the ground, so you do not discharge electricity on the components. You use it like this. Most of the devices have, ESC protection, the ground sign. We just connect this bracelet to the ground, and after that I can open it or close it. Doesn't matter the device is on or off. You always need to use this bracelet before touching any electrical components. In the past, it cost us a lot. They're similar to this RTO, real-time sampling scope, got broken, and we had to send it for repair. It took almost 3 or 4 months to have it back. In addition to the cost that Leslie and others pay for that. So remember this bracelet. If you cannot find a bracelet in the lab, ask Natalie to give you a bracelet. It's better to have a delay rather than explaining to the supervisor why the device is not working. It's got broken. What was I trying to tell you about this company? Okay. Also, I need to show you a couple of problems happened in the lab. Let me find this one. This is there isn't any color, but it's a K-type. Tell me what's the problem of this connector? Yeah, the hole inside that is broken. Tell me what's the problem with this one?
Sheathed around.
If you compare it with another type, you will see that the center got wider. Okay? Yeah, some pressure, they were not allowing pressure and make it wider. See this one? check this one. There's a problem with this one.
Oh,
So you see the problem?
what did you say caused this one? Too much pressure?
Too much pressure and they were
went
not
too far?
aligned.
Oh, they were not aligned. Okay.
Yeah. And sometimes this one is a bit difficult to see that, but I tell you what's the problem with this one. This one is not centered.
Oh yeah, I can see this.
Yeah, you can just pass it.
Have a look.
Next one. We can connect SMA to the K. The size matches each other, but it's not recommended.
Mhm.
Especially we have the adapters. Try not to connect them directly to each other.
How many there are lost?
Loss?
That's a good point.
Yeah,
Using those kind of connections make an additional loss.
it's supposed to have no loss, or at least very small loss, but the loss usually happens in the frequency domain. When you see we check the spectrum of the signal. If it's a small, fluctuation, it's okay. But if you see a notch, for example, suddenly go down and off, it means that it will not work beyond that notch. So sometimes that we see that the spectrum our signal is not good.
What's the problem with this?
It's not centered. You know, the pin is slightly tilted. It's a bit difficult to see that one.
Right.
Yeah, the pin is something like Okay. And we have some people in the lab. They try to fix the cables on the table because you see that the table is so crowded. Sometimes we have to fix the cables. They use mechanical tools, something like this ones. For example, to fix the cable on the table, then put the screw to be sure. They put too much pressure on the cable and they damage the cable. So try not to fix the cable on the table. It must be loose, or just free on the table. That's it. And
Sometimes you use the. Sometimes you use the chest pinch.
Tape.
Taper.
Yeah.
Tape. Yeah, we tape it sometimes, but not always. So, for example, this one power setup we connected. This is our probe to apply the electrical signal. This is the silicon modulator. Underneath of that, we apply electrical signal to the modulator. In the past, there was a DAC here. DAC feed the signal to the RF amplifier via series, and after that, RF probe. See the cables? We try to avoid too much bending because you will see the effect finally, especially when you want to increase the baud rate. And when you do not use a cable, but it's in the setup, put a terminator. See, one side is we close it, the other side. Inside the terminator is 50 ohm resistance. If there is a reflection back, it will not damage it. So if you do not use anything, even over there, in the DAC, you see that. The DAC has 8 outputs with that, but the one that we are not using is the terminator. They open this cable. Zibo, you open this cable, and you open the terminator first because there was a terminator, 50 ohm terminator, when you were working with Lane. Yeah, this one is the terminator. So, and I did here because it can easily get lost. And this one is too much bending. Or it's like this. You do not use it. You have to open it or at least, I don't know. Connect this one to this one. Don't be smart. What else I can show you? You have questions so far? Any question? No? So I told you that most important things, know the colors and the types of the connectors, connecting in the right way. It must easily connect it to each other, go inside each other, then after that use that torque to open or close it. Never forget this bracelet. And not too much bending on the cable. And that's it. I think that's it. And also I use a terminator if you do not use it. Because of the reflection. Something similar to the optical communication. Optical communication when the power is too much. You put the isolator to remove the reflection. And just a few components, maybe it's better talk about that. We have attenuators. Sometimes we need to reduce the power. For example, if I want to see an electrical signal in a device, something like this one, sampling oscilloscope, if you come back here. If you read the things written here, it says that the maximum peak to peak is 5 volts. So I cannot put more than 5 volts to this device. Otherwise, it will definitely damage this one. But sometimes I pass the signal through the audio amplifier. The signal peak to peak string is large, so I have to reduce the signal. How I reduce the peak to peak? I use an attenuator, electrical attenuator. We have 3 dB, 6 dB, 9 dB, something like this. There are the attenuators we have here. Can you tell me the value of the attenuation? You?
10 dB.
Yes. In dB. Yeah. 3 dB. So it reduces electrical power. 19 meters. So that's it. They're the same, but usually keep them here. I try to keep them here, but people do not pay attention. We usually lose it and then we have to search for it. So we keep the adapter here. And when you finish your work, just bring it back here.